Hello and welcome to this video. Now in my previous video I talked about powers, and in the videos before that I talked about calculating with letters. Well, if we combine those two we get powers with letters, and that works actually the same as just powers with numbers. It's just that we don't know what kind of numbers these letters represent. So I'm just gonna write down a random letter here, and we're gonna talk about the powers with letters as a base instead of an actual number. The exponent will be a number. Now, how do I actually get b to the power 4? Well, think about that for a second. What if it was 5? What if it was 5 to the power 4? I would have to do 5 times 5 times 5 times 5, which is 5 to the power 4. So what do I actually have to do to get b to the power 4? I have to do b times b times b times b, which is b to the power 4. Well, this is still pretty doable, right? And so what if we combine this with multiplying our brackets? So let's try and solve this. A times a plus ab plus b times b times b. Well, what's the first thing we need to do? We need to get rid of the brackets. Well, I can't add these two because I have an a and an ab. These are not the exact same letters. So I have to multiply out the brackets. And I do that by multiplying a with a and a with ab. And if I multiply a with a and I do a times a b plus b times b times b, this is what I get. Now I do the multiplications, and now here comes the powers. So a times a, I would write that down exactly like 2 times 2, which means 2 squared. So a times a gives me a to the power 2. Now I have a times ab, and this may sound a bit weird, but it works exactly the same. There's actually a multiplication sign here. So if I do a times a, I get a to the power 2. Then I multiply it with b. So this is what I get. And the last thing is b times b times b, which I also get a power, which is b to the power 3, because I multiply b with itself 3 times. And I can't simplify it any further than this. This is my final answer, because a squared is not the same as a squared b, which is not the same as b 3. So keep that in mind when you're working with letters and powers, that a is not the same as a to the power 2, and a to the power 2 is not the same as a to the power 3. I can't add these together. I just can't, because these are different terms. Just like I can't add a to the power 2 to a to the power 2b. It's a different term. The letters are not exactly the same. Okay, let's move on to something a bit more complicated. What if I would have a squared and I would multiply that with a to the power 4? What happens then? If I just write this all out, let's just write this all out. I would get, I would do this one first. I will get a times a, right? Because that's what a to the power 2 means. And then I will multiply that with this, which is a times a times a times a. Wait a minute. There are all multiplication signs between all the a's. So that means I count all the a's. 1, 2, 3, 4, 5, 6. The a's get multiplied by itself 6 times. Now this means that I have a to the power 6, because that was what that means. Remember, if I can write this down shorter by just saying 5 to the power 6. The same goes for letters. So if there are all multiplication signs like this, I can just say a to the power 6, which means a gets multiplied by itself 6 times. Now there's a rule here hidden in this. If I have a to the power 2 times to the power 4, it's actually the same as saying a to the power 2 plus 4. I actually add the two exponents together, which gives me a to the power 6, because we've seen it here. We've seen it happen here. Okay, knowing this, what would happen if I have x to the power 3 times x to the power 2 times x to the power 4? What's the answer to this question? How can I simplify this? Well, what I actually do is, because there are all multiplication signs here, I can just write it down like x to the power 3 plus 2 times x to the power 4. So I can add these two exponents because it's the same letters that get multiplied. And again, I have the same letters that get multiplied. So I can add the exponents together, which gives me x to the power 9. And if you're having trouble with this, it's okay to just write it all out. You can just write it all out. And it will look something like this right here. And then you can see that there are all multiplication signs between the x's. And because it's all x's, I can write it down as x to the power 9. Now, how would it work if I had, for example, 3x to the power 4 times 2x to the power 3? Try and simplify this. I have to first calculate what 3x times 2x is. 3 times 2 is 6. I have the same, now I have the same letter, different exponents, so I don't have like terms, but because it's the same letter that gets multiplied, I can just add the exponents like this. So x to the power 4 times x to the power 3 is x to the power 4 plus 3, which is x to the power 7. Which means if I have to simplify this, 3 times x to the power 4 times 2x to the power 3, I get 6x to the power 7. Now let's do a more difficult one with negative numbers. Let's say I have minus 3x to the power 3 times minus 2y to the power 6 times 7x to the power 8. Now we have all multiplications here, so no addition. So we don't need to look for like terms. We can just multiply it all together. Now what's the first thing we do with multiplication? We first multiply the numbers in front of the letters, which means I have minus 3 times minus 2 times 7. Well, minus 3 times minus 2, so minus 3 times minus 2 is 6. It's positive because I multiplied two negative numbers. Now, 6 times 7 is 42. Okay, so that's that part. Those are the numbers. Then I have to multiply the letters. What is the outcome of this? What is the outcome of this? Y is not the same letter as x, so I can't just add the exponents all together. However, I do have an x here and an x here, which have exponents, and I can add those together. So what I can do is write it down like this. It's the same outcome. When I have only multiplication, I can change stuff up, because if you see in the example, 2 times 3 times 1 is 6, and 1 times 3 times 2 is also 6. So it doesn't matter in which order, as long as it's all multiplications. So I can write this like this. Then I have an x to the power 3 times x to the power 8, and I can add those exponents together because I have the same base. And if I have the same base, I can add the exponents together. And because I multiply letters, I don't have to write down a multiplication sign in between. So here in between, there's no multiplication sign anymore. And then I just have to add it all together. So my final answer, when I have to simplify minus 3x to the power 3 times minus 2y to the power 6 times 7x to the power 8 is 42x to the power 11 y to the power 6. So this is my final answer because the numbers multiply together and make up this, and the letters multiply together and make up this. Then I just have to put it all together and I get this answer. Now remember, this only works with multiplication. If I, for instance, have t to the power 3 plus t to the power 5, I can't add these two because they are not like terms. I have to simplify t to the power 3 plus t to the power 4. I can't really write it down any different because these and these are not like terms. So the only thing I can do is just write down what's actually already there. I can't add those together. Now with multiplication, I can multiply these because with multiplications we don't look at the like terms. And we have the same base here. We have a base t and a base t, even though we have different exponents. We can still add the exponents together because we have a multiplication between two powers with the same base. So with this, we can actually write down t to the power 3 plus 5, which is t to the power 8. Big difference between addition and multiplication. And of course subtraction, because it works the same as addition, but then with a minus. And then another thing, if I have, for example, a t times t to the power 3, I can't just add this 3 to that 3, because that 3 actually belongs to the a. It actually looks like this if I write down all the multiplication signs. What I can do, however, is simplify it a bit by adding the exponents here. And you might be thinking, well, this t doesn't have an exponent. Well, actually it does. Because like with what you learned with squares, is that all letters and all numbers, if it's just one number, it actually has an exponent of 1. It just means 1 times 5. Or in this case, t1 is the same as t. So it actually has a 1 as an exponent, and I can add that 1, so don't forget that 1, to the 3, which gives me a to the power 3, t to the power 4. So that's very important to keep straight. With addition and subtraction, you can only add like terms, and this t and this t are not like terms, so you can't simplify it any further. With multiplication, you actually can, and if the base is the same, you can actually add the exponents, like this. But if the base is not the same, you can still multiply everything, but you have to look at the same basis for you to be able to add the exponents together. So you can't just add this 3 to this 3. That's it for this video about powers with letters. Practice this a lot, and I wish you all a very good day.